Welcome back. So let's now discuss the C hyperparameter. So we said that the C hyperparameter can be viewed as a way of controlling overfitting, right? So how we can do so? Let's say we want to decrease C, right? We will decrease C. Instead of C being equal to 0.1, we will make it equal to 0.005, 0.00001, and so on, right? So let's say we want to decrease C until it reaches 0, right? So if we decrease C, then we are reducing the bias and increasing the variance. So if we increase the variance, this means we are increasing the chance of overfitting, right? So this also means we become less tolerant to violations of the margin, right? So the margin will be narrower and narrower and narrower, right? So if we make C equal to 0, so we are decreasing C more and more and more, right? We will focus on hard margin, right? We will go in the direction of hard margin, right? So we said in the last lesson that if we just take this part of the equation, right? This part of the equation is for hard margin. So if we just focus on this part, then this means we have something like this. All the data points need to be classified correctly. We don't really tolerate any misclassification, right? If we increase C, right? If we increase C here or here, then we are allowing misclassification. So this way we are going in the direction of soft margin, right? So decreasing C will reduce the bias, increase the variance, so the margin will be narrower and narrower, right? So we become less tolerant to the violations of the margin. And if we increase C, the opposite will happen. The bias will increase, the variance will be reduced, and we become more tolerant to the violations of the margin, right? So how we can choose C? C is generally chosen via cross-validation. So we do cross-validation, we check with C equal to 0.1, with C equal to 0.5, 1, 100, 1000, and see what is the best test accuracy, because we don't really focus on the training accuracy. And the test accuracy in this case will be the validation accuracy. So we use cross-validation in order to find C. So C is very, very important for controlling overfitting. If we decrease C, then the chance of overfitting will increase. And if we increase C, right? So if we decrease C, the chance of overfitting will be higher and higher. And if we increase C, the chance of overfitting will be lower and lower. But at the same time, if we increase C so much, then we will have a very, very large or very wide margin, right? We will have a very wide margin in this case. So in this case, the training accuracy itself will be low, right? So we will go in the direction of underfitting. So increasing C will lead to underfitting, right? And decreasing C will lead in the direction of overfitting. So we want to find the sweet spot of C, the optimal value of C, or the best value of C that doesn't really overfit or underfit. Okay, so this is very, very important hyperparameter. Now in the next lesson we will discuss the kernel trick. Okay, we discussed what do we mean exactly by the kernel, but we will discuss in the next lesson why it's a trick and why it's actually pretty good with the SVM, right? And after that we will see how we can choose the C hyperparameter and perform the cross validation. So let's go to the next lesson.